function is continuous does not mean the function is differentiable. Graphically, a function is not differentiable if, number one, the function is not continuous. Number two, the second thing we found was if there is a point of inflection, yeah. Or three, if it's a bird.
We'll just say that.
It's if they call it a cusp
You're funny.
exists.
I am. Did you hear my joke?
No, what'd you say?
It's a bird, it's a plane, it's not differentiable.
I love it.
Thanks.
Okay, so a cusp means it's going to change directions, not fluidly. It has, it just changes
So fluidly
quickly.
would be like little valleys
Like
and
a
mountains.
curve, and it's just, yeah. I wish you could see Ashley. She's like, oh my goodness. But yeah, if it was doing it fluidly, then yes. If not, then it's going to cause
How
a
do you
cusp.
change directions fluidly? You're like a U-turn because it's
Like
fluid.
you're going,
Fluid.
that's fluid. So it's not fluid. Yeah,
I just go boom.
that works too. We're going to call it the bonk.
Yeah.
So in order for a function to be differentiable, two things have to be true. One,
We just wrote this.
No, we wrote why it's not going to be.
f of
It
x
has to be
must
Continuous.
be continuous.
I'm getting tired of writing f of x.
Same.
Then why?
The limit as x approaches a from the left-hand side of the derivative of f of x, so of f prime of x,
We just started limits.
has to be...
I thought we were done before.
Me
No.
too, because I completely forgot how to do it.
Me too.
No, you haven't. We just did limits when we were doing
When I said
continuity.
2, I was guessing.
Well, I don't know how to find the limit without a graph. I forgot.
I don't know how to find a limit in general.
Oh, I left out the word means.
Honestly, I don't think I knew how to do the limit when I took the test.
So, f of x has to be continuous. If it's not continuous, then it's not differentiable and you'd be done. If it is continuous, then you also have to look for that the limit, this is making sure there's no cusp and making sure there's not a point of inflection there.
So if it has both of these, it's differentiable.
Differentiable, yes.
That word is probably never going to come out right now.
I love you, Faith. I can't help it. Okay, so we have this function. It's a piecewise function. Lovely.
Yep.
And so we're going to figure out first if it's continuous at x equals 3. So if it's continuous, hey, it's g of x now. No more f of x. We have to show if g of 3 exists.
Hold on. If f of x is y, what is g of x?
Why?
Y. That's also y.
W means Z? There ain't no W.
It's a, z, f, g, x, or y.
So g of 3, does it exist? Yes. Which equation is g of 3? Yeah, the top one, because the top one is or equal to 3. The bottom one is not.
true.
So that's why I'm only using the top one. So G of 3 equals square root of 3 plus 1.
4, 2.
That sounded like it should be a cheer.
I know, right? So G of 3 exists.
I can't write it.
God.
So then number 2, I need to look for the limit as x approaches 3 from the left.
So that's 2.
Yeah. As x approaches 3 from the left, I use the top equation
Yeah.
Why?
because this is to the left of 3.
But the other one's still gonna be 2.
And the limit as x approaches 3 from the right is 5 minus x, which is indeed 2.
Okay, cool. So I didn't lose everything.
So the limit as x approaches 3 of g of x exists.
I just thought it was part of the actually.
Equals 2. And so therefore, limit as x approaches 3 of g of x equals g of 3.
If I draw you a picture, do I
No.
So all I heard was if I draw you
a picture?
You probably heard it right then.
g of x is continuous at x equals 3.
I just thought of how you made that blue snake for Olympiad instead of in last place.
I know. I got 8 out of like 34 with a
If
big
g of x is differentiable at x equals 3, is g of x differentiable?
No.
Show the complete analysis.
Probably. I hope.
So, step 1,
There's
According-
no point.
according to up here,
It's continuous.
step 1, you got to show that it's continuous. So yeah, it is continuous.
So we gotta find the limit of prime. That's it.
It's not as bad as you think.
Yes.
I think it
I gotta find the prime, and then I gotta find the limit of the prime.
So first, I'm going to rewrite g of x down here so I don't have to keep scrolling up. Plus, I'm going to write it so I can take the derivative of it.
Okay, how do I take the derivative? Actually, I'll just watch. Shut up for a second.
it'd be like 1/2 x plus 1
Yep.
negative
How do you draw the little squiggle without turning the paper
times
sideways?
1, which is nothing.
So to take the derivative, I just take the derivative of each of those.
Oh, that's easier.
So that would be 1/2 x plus 1 to the negative 1/2
Technically times 1.
times 1. Yes, very good. I was thinking that. Very good. And it's still from 0 to 3. That doesn't change. And then the bottom one,
1.
close.
0.
Negative 1.
Negative 1.
Why?
Because there's a
'Cause it's-
negative.
Okay.
Whatever.
So we know the answer to 1.
So I'm just going to make it look like 1 over 2 the square root of x plus 1.
So you just took all math out of it. Good. I don't want to do it.
I just put that in the bottom.
I'm tired of this. I can't move.
I just don't know it.
So we do the limit as x approaches 3 from the left of g prime of x. Well, from the left, g prime of x is this one or this one.
Oh,
So all that means is we're just plugging in 3 into that equation.
it's 1/4.
So it's 1, let me change the color here so you see the colored coding. 1 over 2 times the square root of 3 plus 1. So it's 1/4, right?
Yeah. Unless I did math wrong.
Then the limit as x approaches 3 from the right.
It's negative
I
1.
wonder what this is.
Negative 1.
Yeah, that one, it's just negative
They're
1.
not equal. It does not exist.
So, the limit as g prime of x as x approaches 3 does not exist because those two limits are not equal to each other.
Therefore, not differentiable.
Oh, just at that point, but yes. At 3.
When are we gonna get one that is defined?
Never.
That is a good point. We've yet to have one.
We have another
Well,
one.
all the other graphs that we've been doing have been differentiable.
Oh, the ones before?
Yeah, like
Okay.
all the other problems. Now we're just
I was like, we haven't
nitpicking.
had a single one.
No, but all the ones, I mean, before this lesson. It's almost time, Ashley. Can you handle it?
No.
What's happening? Oh, the bell.
The bell. We'll stop there.
Really?
When does the
Don't
bell
ring now.
ring? It rings like right now, right?
Oh, great.
Wait, what?
When does
No.
the bell ring?
30
No,
minutes.
yeah, you have
Should
4
like
minutes.
5 minutes.
Oh!
We shouldn't have told her that.
Thank you.
We should have been like, oh, the bell must have turned off.
I have to go to the restroom.
I don't know why I thought it was like at 26.
It is.
It is at 20.
That is at 26. The bell is not.
That's what I mean. I thought the
30.
bell was
Yeah,
at
it's like
20.
30.
31. Okay, that's what I'm thinking of.
Honest mistake.
Honest. And y'all were honest. I appreciate it.
Probably should.
Okay, so for what values of k and m will the function below be both continuous and differentiable?
We just know.
No. It
Okay.
never works.
At x equals 3. So, no, we're making it continuous.
Oh,
We're
no.
finding k and m.
I hated this stuff.
Oh my god.